Remember those days back in the early video era, meaning all of the 70s, 80s, and most of the 90s, when this quality was used to be today's HD? We've come a long way since those glorious VHS tapes, picture quality-wise. I'll explain this in this two-part video, what video resolution is, its origins and differences, so grab the popcorn, get yourself a soda pop, and enjoy the ride.
Relax. My VHS home video recorder is taping it right now.
Terrific. Watch. Terrific. But suppose it's over 3 hours.
Relax. Panasonic VHS tapes up to 4 hours of sports, movies, specials on one cassette.
Wow. This VHS is for me. You caught the whole game.
Best catch of the day.
Yeah.
VHS, the 4-hour system from Panasonic and other leading companies.
Now, if you notice the YouTube adjustment display button in the shape of a cog, you'll see the quality option, which refers to the video resolution, which, by the way, it amounts to only one aspect of picture quality, even though it says quality. The higher the number, the better the image, right? 144p, 360p, 720p, 1080p, and 2160p or 4K. It's a freaking alphabet soup, I know. All of it refers to resolution, the amounts of pixels. But what's a pixel? Well, a pixel literally means picture element, which translates to the minimum unit of a picture. Digital images need these tiny dots to create an image, and they need quite a lot. The more dots, the more resolution. Simple. Have you ever zoomed in a picture so much to the point of seeing grids of squares known as pixels? Hence the name of getting a pixelated image. Actually, even though a pixel represents exactly the same thing for photography and video, their interpretation in the physical world differs a bit. Let me take you back to the mid-50s when color TVs was introduced to the American market. The analog era. Woo!
Enjoy your favorite programs, black and white or color. Turn the set on. Select your channel. See all color shows in living color.
Before there was color, the term or idea of pixel didn't really mean anything with TV sets because the image was created thanks to a cathode tube, a heavy, big old tube that with the help of electrons, beams, excited some phosphors that creating a moving image. Did you get all that? All right, stay with me. In other words, the TV's black and white image consisted of merely one pixel. This black and white TV has only one beam light behind the screen, creating one picture element. Now, you might be wondering, that's cool and all, but how do we get movement? Well, that's thanks to a clever but not so perfect trick. In order to create a moving image, the signal would divide the picture, creating two horizontal line patterns. So that would mean to get a jump from frame A to frame B, the even lines would create image A and the odd lines image B. This is called, ladies and gentlemen, interlaced video or an interlaced moving image. And this horizontal division, it's embedded in the signal and the TV reads it and interprets it. Remember my negative remark a few seconds ago when I said this wasn't perfect? With rapid moving images, well, this creates a distortion, the undesirable combing effect, as the word comb, consisting of a halo-ish / ghost image retaining the previous frame and the lines becoming more noticeable. Have you ever seen in a modern movie where they poorly try to recreate the combing effect with all fashion transmissions? To create color, you need, well, color. Duh. Color filters more precisely. Primary color filters to be even more precise. Red, green, and blue filters, which combined create a secondary colors, cyan, magenta, and yellow, and the combination of primary and secondary colors ultimately create all the color spectrum a human being can perceive. Therefore, TVs observed up close started to look like this. Filters are tiny dots containing red, green, and blue. And voila, let there be color. This would shape the way pixels are designed. Now, the folks at Sony, the good Japanese engineers, invented a patented technology that would improve the picture quality and brightness of these old TVs, color TVs. I'm referring to the Trinitron Tech, whose TV sets implemented vertical strips of red, green, and blue filters. See the picture quality difference here? Now, up until this point, these color elements were not pixels. They were just grids imposed over the image. Bear in mind, these were still 1 pixel televisions. I'll explain later on the difference. Now, if we come back again to the interlaced technology, it has 240 lines, even lines, and 240 odd lines, which amounts to a total count of 480. Does 480i ring a bell now? So the first idea of resolution was the count of the horizontal lines or fields, meaning the name of a resolution would contain the line count from top to bottom, though these were not yet pixels. A horizontal line is occasionally called field because to Philos Farnsworth, who invented the electronic TV, these lines looked like sowing fields. Time break now. Let me take a sip of this delicious beverage. So refreshing. So far so good, right? Now we delve into the home video world. Now up until the 90s, this was the best video quality you could get. I'm talking about videotapes. Magnetic tape was for many years the main source of storing, mastering, and delivering content to your good old cathode tube. From TV programming to home entertainment, the tape delivered a maximum quality of 480i for interlaced fields. Now you know what I stands for. In a square 4:3 aspect ratio. However, the image quality would decrease with each viewing since the tape would wear off. I remember watching as a kid a Michael Jackson concert tape as a kid 1 trillion times, and as a result, the VHS ended up being unwatchable. Now you can find these tapes and their players, which are called VCRs, at your grandparents' home since the tech's been deemed obsolete. We can thank computer graphics and 8-bit video games where the concept of pixel truly originated, which helped to create whether letters, game characters, like Mario for example, but literally using colored squares, true pixels, inside a 256 by 240 pixel grid. And if you do the math, it's 61.4 thousand pixels. Nothing compared to the 2 millions we're used to seeing. Now, each dot or square is a true pixel element, which combined make up an image. The geeky nerds started to ask whether it was possible to create high-resolution moving images using complete digital schematics. Well, the answer was yes, but not so high resolutions. And since the vertical number of interlaced fields was 480 already, they decided to stick with it and created the first or better said, first successful digital video format with a 720 by 480 pixel resolution count. Welcome the DVD.
This is DVD. And this is what happens when you watch DVD. It's a movie on a disc the size of a CD. The picture is twice as sharp as VHS. The sound is infinitely clearer. It looks and sounds like you're at the movies, but you can experience it at home.
Ooh, looking good, right? Released in 1997 in the United States, the jump from VHS to DVD was huge. Not only due to a crystal clear picture, but also to the optical format. A CD to watch movies? Are you kidding me? This was a big deal and the beginning of a new era. First of all, the format ditched the archaic interlaced tech and replaced it for the progressive tech, which means no more weird horizontal lines doing tricks, getting a complete picture with each frame, hence the name 480p. The Matrix DVD was the biggest breakthrough for the technology, which led it to be massively adopted. Did you need a new player? Yes, you needed one. Did you need a new TV? Not really, nope. Your good old color TV would do. Even though to take the best advantage of this new technology, flat screen TVs were needed because old ones had curved front panel glasses. No millennials, not that curvature. Actually, it's the one that looks like a TV belly. And flat screen TVs started to get hype in the mid-90s. And these ones actually got pixel count. They were 640 by 480, creating a 480i image, 307,200 pixels to be more precise. Hold on a minute. A DVD could hold more vertical lines 720 and have progressive frames. Why didn't this translate to the TV sets? The answer is the content wasn't available yet, and the TV programming and local news were just starting to adopt the transition to digital, so most of the consumer content was still 480i during the 90s.
Viewers will have access to 2 forms of digital television from January 2001. After months of lobbying by Australia's media barons, the federal government today announced a compromise.
Today marks an important milestone on the road to the new world of digital television.
While Channel 7 is pleased, the other commercial networks are not. They say so-called triple casting will mean a slower and more limited introduction of digital TV. But the Consumers Association says it's a win for viewers. Instead of paying up to $10,000 for a new TV, viewers will have options like a converter box for as little as $500.
Now, if you put a magnifying glass to your TV screen, or simply your nose close enough, you'll see the grid on your brand new 1998 flat TV screen with Trinitron technology. Super duper, right? Now, each trinity of color filters, red, green, and blue, represent 1 pixel, and each color is referenced as 1 subpixel. So 1 pixel will have 3 subpixels. And us consumers could finally see razor sharp images, an increase in television size, and begin our journey into the HD world. I hope you've enjoyed and learned from this both technical and informative video, and we'll see you next week when we'll tackle the high definition concept. Hit the like button and subscribe if you reached this far. I'll see you in part 2. Ciao. Curvature. Started to gain, and flat screen TVs started to gain hype in the mid-90s.